26. You're asked to go ahead and graph this and find the area underneath your curve. So I would start out by putting this in my y equals. Then I would go second window, table start at 1. Delta table should be 0.5 because it tells you go up by half a unit increments. You would then get this table, plot these points, and you would get what I have over here. Then you could draw in your curve. Now you need to go ahead and find your area. Well, we could use rectangles. If we go ahead and do a right endpoint rectangle, you'll notice we're kind of missing an almost triangle shape. If we go ahead and do a left endpoint rectangle, we're adding in almost a triangle shape above. So doing our left and our right is going to end up adding or missing some given area that we're looking for. So what we could do is not use rectangles, but use trapezoids. So I'm going to come up here and then do this one, and then do this one. And you'll notice when I do a trapezoid, it comes pretty close to the actual curve. Yes, it's a little bit off, but it is pretty close. So it's still going to give me a fairly accurate answer if I do trapezoids. So if I do trapezoids, I would have my trapezoid formula, do my first trapezoid, which would be this one right here, 1/2. My first base would be the height of the blue, which is at 7. We get that from our table. And then our second base, which would be the first black, which is this one right here, which you get when you plug in 1.5. Times our height. Your height is how far the bases are apart. And then we'd want to come along and do the next one. The first black base plus your second base, which is what you get when you plug in 2, times how far apart the bases are, and then just keep doing this. And that's how you would go ahead and find the area or approximate the area underneath this curve. And then you could work all that out with your calculator. In the next problem, you're asked to go ahead and graph this, starting at 3, going to 6, going up by half unit increments. So I'd have put this in my y equals, switch my table set to start at 3, still with half unit change for your delta table, being 0.5. Plot your points and we get this down here. And we would get this similar graph. Now once again, if we did rectangles, we would either include a little bit more than we should, like we kind of have a triangle shape above, or if we did a left end point, we'd have a triangle shape up below our curve that we're missing out. So triangles are not necessarily the best, or rectangles are not necessarily the best. Once again, we will try our trapezoids. And is a trapezoid going to be perfect? No, because our diagonal that we're putting in here is straight, where the red is curved. However, it's still going to do a pretty good job of approximating it. So, just like on the last problem, we'll go ahead and use our trapezoid formula. We'll do the trapezoid for this first one. 1/2 your first base, which is what you get when you plug in 3, which is 1. Plus your second base, the first black one, and that's what you get when you plug in 3.5, which is 1.2247, times how wide this is, which is the height between your two bases, which is 1/2. And then we'll continue on and just keep doing the next one and so on. So that's how we can approximate the area underneath our curve. And so I'm assuming at this point you guys can go ahead and probably complete that for the rest of your trapezoids and put this in your calculator to get your answer. You're then asked to go ahead and find your area underneath pretty much the whole curve, the area of the blue plus the area of the red, because it's a piecewise function and you're looking for your area from 1 all the way to 6. Basically, you take your area that you got from underneath the blue and add it to the area that you got from underneath the red. You add those two together and you get your answer.